Furnaces are an important source of heat for many industrial facilities. Furnaces, which can also be referred to as fired process heaters, are basically enclosed structures that produce heat by the combustion of fuels. Although furnaces are used in a variety of applications, the basic components, operating principles, and operator responsibilities are similar for most. To become a safe and skillful furnace operator, you need a good grasp of the basics. In other words, you need a solid understanding of furnace fundamentals before you move on to specific operating procedures and responsibilities. So let's take a look at a typical furnace. This one consists primarily of a large box or shell and a stack. During operation, heat is produced by combustion inside the shell. The exhaust gases are routed to the atmosphere through the stack. In this furnace, the heat is provided by burners that are located in the floor of the shell. This type of furnace is a floor-fired furnace. Some furnaces are wall-fired, while others may use both wall and floor burners. In addition to burners, furnaces contain many other important parts. Inside this furnace, tubes carry the process fluid through the furnace. The process fluid enters the furnace in the tubes near the stack, passes through the tubes, and leaves near the bottom of the furnace by the burners. The tubes in this furnace are grouped into two major areas. This area, which is closer to the stack, is called the convection section, and this area, which is closer to the burners, is called the radiant section. The shell of the furnace is lined with a heat-resistant material called refractory. Now let's look at some of the basic systems that furnaces rely on for proper operation. One of these is the fuel system, which delivers fuel to the furnace. A typical fuel system includes fuel lines and valves that carry the fuel to the burners and control its flow. On furnaces that use oil as a fuel, the fuel system also includes a fuel pump. Furnaces also need air systems. An air system is needed because the burners in a furnace mix air with fuel for combustion. Airflow to a furnace can be controlled in different ways. For example, on some furnaces, airflow is controlled by registers and by the stack damper. Air is drawn into the burners through air registers. The registers can be opened or closed to let more or less air into the burner. The stack damper is used to control the flow of gases leaving the furnace. This also affects the amount of airflow that can enter the registers. Opening or closing the damper increases or decreases the amount of air that flows into the furnace. In some furnaces, air circulation is accomplished using fans. These furnaces are called forced draft furnaces. In other furnaces, air circulation occurs naturally. These furnaces are called natural draft furnaces. In addition to the fuel and air systems, furnaces also have a process fluid system. This system includes the tubes that carry the fluid inside the furnace and the pipes, valves, and pumps outside the furnace that move the fluid and control its flow. To keep track of all these systems, furnaces use instruments. Some of the instruments are located near the furnace, while others may be in a control room. Instrumentation and control systems allow operators to keep track of the overall operation of the furnace and to adjust operating conditions when necessary. Furnace control systems also have alarms that alert operators to abnormal conditions. Operators can then take action to prevent dangerous conditions from occurring. All of the parts and systems associated with a furnace are used to accomplish one basic task: heating a process fluid. We can get a better understanding of how this is done if we break the furnace operation down into three basic actions. In the first action, air and fuel are introduced into the furnace and then mixed together by the burners. The mixture is ignited at the burners. As the fuel burns, a chemical reaction occurs and heat is produced. In the second action, heat released by the chemical reaction created by burning fuel is transferred to the process fluid. The fluid flows through the tubes inside the furnace and receives heat by conduction, convection, and radiation heat transfer. In the third action, the combustion gases that are produced by burning fuel rise through the stack and are exhausted to the atmosphere. In this topic, we looked at some of the major components and systems that make up a furnace. We also looked at the basic operation of a typical furnace. In a furnace, heat is produced by the combustion of fuel. Basically, combustion is the process of burning. In order for combustion to occur, 4 requirements must be met. Combustion requires fuel, air, heat, and a chemical reaction. When all 4 requirements are met, combustion will occur. Several types of fuel can be used in furnaces. Most often, the fuel is either gas or oil. Air is required because it contains the oxygen that is needed in order for fuel to burn. Heat is required to raise the temperature of the air and fuel high enough to make the chemical reaction possible. The chemical reaction is the actual burning of the fuel. When fuel, air, and heat are together in the correct proportions, the chemical reaction occurs. During furnace operation, the heat that's produced is transferred to the process fluid. Heat transfer occurs whenever there is a difference in temperature between 2 materials. When there is a temperature difference, heat transfers from an area of higher temperature to an area of lower temperature. Heat transfer can occur in 3 different ways: by conduction, by convection, and by radiation. Conduction is heat transfer as a result of physical contact between 2 materials, or heat transfer from one part of an object to another part of the same object. For example, conduction is the means of transferring heat across the walls of the tubes inside a furnace. Another form of heat transfer is convection. Convection is the transfer of heat within a fluid that occurs because of the movement of the fluid. Convection can be either of 2 types: natural convection or forced convection. We'll use this container of water and dye to show how natural convection works. When heat is applied to the container, the water that's closest to the bottom of the container is heated first. As the temperature of the water near the bottom increases, that water becomes lighter or less dense, and it moves upward in the container. At the same time, the water near the top of the container, which is cooler and heavier or denser than the warmer water, moves toward the bottom of the container. This is what happens during natural convection. As heat is transferred to the water, a difference in density is created. This difference in density causes the water to circulate in the container, and the circulation helps to transfer heat throughout the water. During forced convection, fluid movement is produced by a mechanical device, such as a pump or a fan. A good example of this type of heat transfer is the forced convection heating systems that are used in many homes and buildings. With this type of system, fans force warm air into the rooms that are to be heated. The warm air then mixes with the existing cooler air and heat transfer occurs. The third form of heat transfer is radiation. Radiation is the transfer of energy by electromagnetic waves. For example, the sun gives off large amounts of radiant energy in the form of electromagnetic waves. As the radiant energy travels through space, the waves that are in a direct line of sight between the sun and the earth come into contact with the earth. Some of these waves are reflected off of the earth, but others are absorbed by the earth. When a wave is absorbed, its energy is absorbed by the earth as heat. The amount of heat transferred depends on the number of electromagnetic waves absorbed. In a furnace, radiation, convection, and conduction are all involved in the transfer of heat from the burning fuel to a process fluid. The burning fuel produces radiant energy that travels through the combustion area or firebox. There is a direct line of sight between the flames and some of the tubes, and the outer surfaces of these tubes absorb heat from the electromagnetic waves that contact them. Radiant heat transfer is not the only type of heat transfer that takes place in the radiant section of the furnace. Some convection heat transfer also takes place. When the burners are firing, the gases near the burners are the hottest. As these warm gases mix with the cooler gases surrounding them, heat is transferred by convection. The tubes in the upper part of the furnace are not in a direct line of sight with the burner flames. Most of the heat transfer that takes place in this area occurs by convection, as the hot combustion gases pass around the tubes. This part of the furnace is called the convection section. Heat transfer by conduction also takes place in a furnace, as the outer surfaces of the tubes get hot and transfer heat to the cooler inner surfaces. Heat transfer by convection also occurs within the process fluid, as hot fluid inside the tubes transfers heat to the cooler fluid. In this topic, we discussed the 4 requirements for combustion, and we saw how combustion occurs inside a furnace. We also examined 3 ways that the heat from combustion is transferred inside a furnace.